Yeah, thanks for having me. So I am going to talk a little bit about high tunnels and a little more broadly about soil health on diversified vegetable farms and some of the things that we learned in a project that our team did 2 springs ago now, in 2023, called the 100 Farms Project. Um, and I think some of you have already heard me talk about this. So sorry for the repetition, but I kind of condensed it down to the highlights. Um, so I'll just take like 20 minutes, I think, and go through some of what we learned on this project. So share my screen here. There we go. All right. So I'm an extension educator in Minnesota. Um, I'm a vegetable crops educator and I cover the whole state. And I've been doing this for almost 8 years. And I didn't start out working with soils at all, actually. I was trained more as like a kind of a general agronomist. But as I have been in this position, visiting farms, looking at people's soil tests, I became more and more interested in soils just because I saw that people had so many questions and we didn't have a lot of good guidance for diversified farms. Um, and partially because my part of my background is in freshwater ecology, and I was seeing a lot of soil tests with really, really high phosphorus levels. And I wanted to better understand just kind of the landscape of soils on diversified farms. And then as more and more people were building high tunnels over that period, um, there was kind of this narrative that high tunnels are really productive for like 3 to 5 years, and then we see a steep decline. Um, and I had a lot of ideas about why that might be, but no super clear answers. And so I put together this study to better understand what was going on in high tunnels, to look at just generally how do high tunnel soils change over time, and to look into these narratives. One being that soils in high tunnels become like depleted or tired because we expect so much of them. We're producing really large volumes of vegetables over an extended series or season. And so there's kind of this narrative that like the soils just become depleted from that really intensive production. And also some questions about salinity issues in high tunnels. Um, and then kind of zooming out a little bit too, I was really interested in that phosphorus question and also in compost. I see more and more farms use a lot of compost for various reasons. One being just this idea that like more organic matter is always better. So let's just keep using compost. Some people using compost as a mulch. And then as more and more people are interested in no-till, I think compost and really heavy applications of compost is like one of the main ways that we do no-till on a really small scale. So put together a team of 17 extension educators across Minnesota. And we, over the course of like 2 months in the spring of 2023, went out to 100 diversified small scale vegetable farms. And we took a bunch of soil samples, looking at kind of your standard soil tests that you might get from a soil lab every year, but also a number of other soil health indicators. We also had the farmers do a survey so we could correlate some practices with what we were seeing in people's soils. And we were defining small scale as anything less than 50 acres, but the average farm in this study had 5 acres, and the average person was about 7 years into production. I think I said that wrong. The average person hadn't necessarily been farming 7 years, but the average farm had been in vegetable production for 7 years. Yeah, so this was our team of educators on the map, and then our team of researchers looking at these soils. It was funded through the Minnesota Ag Experiment Station. And so I'm going to just zoom way out to start with the big picture here. So this is looking across high tunnels and fields. And I'm going to start with some bad news, which is that when we looked at soil health, really basic soil health indicators, mostly from a physical perspective. So organic matter, aggregate stability, and bulk density. So bulk density being a measure of compaction, aggregate stability being basically is our soil forming aggregates. So aggregates being kind of clumps of soil and organic matter that are held together with root fragments, some kind of natural glues that come from plant roots, insects, microbes, etc. So when we looked at aggregates in the soil, compaction, and organic matter, the things in red are the things that significantly negatively affect soil health. Gray is neutral, and then green is good. So the more time someone had been farming, the more years in production, basically soil health was worse on vegetable farms. And actually farm size as its own variable didn't really have an effect. So regardless of farm size, one kind of really high level takeaway was like, maybe vegetable production is kind of hard on the soil. But some good news is that we saw in this project that conservation practices do significantly improve soil health on vegetable farms. So this was kind of interesting, organic practices. There was a spectrum from certified organic to using mostly organic practices to conventional. And as people moved towards certified organic production on that spectrum, we saw organic matter and bulk density improve. And we actually saw a difference with certification. Soil test frequency had no impact. So testing your soil did not actually correlate to any change in your soil health. Cover crop use actually had a negative effect, and I'm going to talk more about why we think we saw that. Reduced tillage was the most significant factor here. So reducing tillage we could see a meaningful impact on organic matter and aggregate stability vegetable farms that were reducing their tillage. And that's what we expect to see, and it's good to see what you hope to see when you do studies like this. We did see that the use of plant-based composts also improved these couple of measures of soil health. And in this study, manure, either composted or fresh, did not really impact soil health. But I will say there are plenty of other studies that do show this. And we were using pretty crude metrics, just asking people like, how frequently do you apply these products versus like measuring inputs and testing a response. So I'll share just a little bit here about these different things, and then I'm going to talk a lot more about nutrient management. But I think this graph here will not come as a surprise to this group. So we asked people to tell us how many deep tillage passes, shallow tillage passes, and manual tillage passes they were doing each year. And so we said deep tillage would be like a rototiller or a moldboard plow. Shallow tillage might be like discs that are set to a certain depth, maybe vertical tillage, and then manual would be like a broad fork. And when people were very small, they did a lot less deep tillage. When people were, getting to a slightly larger scale, they were maybe doing less manual tillage. So that makes some sense. I think this group talks a lot about the fact that on a very small scale, it's possible to just use hand tools like using tarps and flail mowers and broad forks, but you get to that sweet spot of like over 3 acres and we don't have a lot of great options. Organic certification, this is what we see really consistently when we do surveys of growers or projects, that the majority of growers, at least in Minnesota, are not certified organic, but they are using exclusively or mostly organic practices. And so that was kind of interesting to me that people who were certified organic did seem to have better soil health actually than people who just said that they were organic. I think there are a lot of reasons people do or do not certify at a small scale that have nothing to do with soil health. But that was kind of just an interesting thing that stood out to me. So something that is often not talked about as a soil health practice, like often we're just kind of focusing on cover crops and tillage when we talk about soil health. And when we look at the soil health principles, those are kind of the things to focus on a small scale vegetable farm, maybe in addition to just diversity and mulches. I really like to think about nutrient management as a soil health practice, especially when we zoom out and think about the ecosystem health around our farms. So this, I think, is super challenging for small farmers, especially those who are organic. One, because we just lack good recommendations in general, and because overwhelmingly we really tend to rely on compost and composted manures for fertility. So, of the 100 people participating in this study, composted manure was the most common input. So, about 60% of people were using composted manure every year, followed by organic supplements, often together. So, things like blood meal, feather meal. Vegetable compost was fairly common, like 30% of people used it every year. Over 50% used it every few years. And then fresh manure, a little less common. And then synthetic fertilizers, really not very common. And so the kind of inherent challenge when we're relying on manure is that we tend to have more phosphorus and potassium in relation to our nitrogen needs. And so up in the soil. And well, we asked people like where they were getting fertility information. Most people were using soil tests. That was the most common decision-making factor when figuring out how much, like what fertility to add to your soil. But when we asked about how frequently people were using composted manure, which was the most frequently used input, it was really more common to use as much as a person could get, or a set amount, like 1 inch on every bed, versus doing it based on that soil test, which I acknowledge is like complicated and kind of awkward math to do. And what we then saw in the soil, I think really emphasized that idea that maybe we're not using soil tests as much as we should to make decisions about manure. So 87% of high tunnels and 84% of fields had very high phosphorus levels. And so these graphs show just how high then. So here we're showing a lot of people had high phosphorus, but how high? We have 2 ways of measuring phosphorus in Minnesota that depend on your soil pH. So if your soil pH is 7.4 or less, we use this Bray system. And if your soil pH is above 7.4, we use Olsen. And so on each of these graphs, I've marked in red a line at the point we consider to be very high, where we don't recommend additional phosphorus fertilizer. And then if you look at these box plots, these are basically, it's like a spread of the data. So the average person is on that line in the middle of the box. 25% of people are below it. 25% are in this bottom box. 25% are here. And 25% are above. And so if this level is very high, the average person was like, at least in high tunnels, like 2 to 3 times as high is very high. And there were people well above that. So we saw a lot of phosphorus. And I think it's really natural to be like, small farms are such a small footprint on the landscape. Like, does it really matter? We're surrounded by thousands of acres of corn and soybeans. Like, maybe that's where we should be focusing. But one, so soil phosphorus is a really good predictor of how much phosphorus leaves your farm. So in all of these graphs, these are all from studies in the Midwest and Iowa, Minnesota and Wisconsin, and then Ontario. We see someone's soil test value of phosphorus on that horizontal axis, and then a measurement of the amount of phosphorus leaving that farm through runoff. And this graph shows both runoff and tile drainage. So having a lot of phosphorus in your soil, it's very likely that you're going to see phosphorus leaving your soil. And we actually did this whole GIS analysis that we're still looking at. A lot of small farms are in really beautiful places near waterways. So like half of the farms in this study were really close to a wetland or a stream, or some waterway where there was an inherent high risk of runoff just because of proximity to that waterway. And I think even though most small farms are small, people who farm vegetables on a small scale are often also people who really care about the environment. And so figuring out ways to do that really responsibly, I think is part of like the core ethic of why many of us are in farming. Um, I don't really have time to go into this today, but nitrogen levels were also really high. So we kind of expected there to be like low nitrogen and high phosphorus because of this imbalance in compost and composted manure. But many farms also had really high nitrates. So that kind of suggested that we're also just over fertilizing in many cases. So looking a little bit more specifically just at high tunnel soils, the first thing that we saw in this study was that high tunnel soils really were not depleted in any way if we looked at organic matter or nutrients. So the bluish green lines on here are fields, the maroon are tunnels. We had substantially more organic matter in high tunnels than in fields. In Minnesota, we consider about 4.5% to be very high. So our soil organic matter in tunnels was very high. We had really high soil nitrate, and this was just in the top 6 inches. So this means the average person had like about 35 parts per million nitrate. In 6 inches of soil, that's a 70-pound nitrogen credit, like at the beginning of the season before you've applied any fertility. Really high phosphorus, potassium, magnesium, and calcium. So we really didn't see depletion. Instead, what we saw was in about 40% of high tunnels, there were issues with salt accumulation. And we looked at all these different things that could be correlated to salt accumulation. And it actually was mostly inputs. So the main thing that correlated with high soluble salts was high nitrates. So the reason I think that matters a lot is we talk about, if you read like any extension publication about soluble salts in high tunnels, the recommendation is to flood the tunnel to leach the salts. But if the primary salt is nitrate, that means that we're just flushing nitrates out of our soil, like straight into the groundwater, potentially. And so I think part of the solution there is reducing inputs to like really match crop needs. The other challenge is connected to both salts and pH, which is just our groundwater tends to be very alkaline. And I think in Wisconsin, in most of Wisconsin, that is also true. And so we're irrigating with water that has high alkalinity, which then kind of drives the pH up over time in high tunnels. Something that was really hard to capture in any sort of meaningful like data collection way, but we all noticed like physically, experientially, was that in a lot of high tunnels, the soil was really dry. And we were able to capture that when we did infiltration tests. So we did a test that mimicked 1 inch of rainfall. So we poured 107 mils of water into a 3-inch diameter, or no, 3-inch depth cylinder. And in, I think 27%, that water was gone in less than 30 seconds. And we added a 2nd inch and it was gone in less than 30 seconds. And there were some where it was gone in like 2 seconds. And what we saw and what some farmers have been reporting is that when you've been adding a lot of compost to the surface of soil, you almost get this separation. It's almost like a hard pan layer where you have like compost and then soil. And especially if your soil is a bit heavier, if you have more clay, you can get this dynamic where the compost dries out and then it becomes hydrophobic. And if you're trying to germinate seedlings, it's like you have to keep watering to get any sort of water retention in that compost. But then the soil below it becomes saturated. And there are a few tunnels now that I've been working with where people have this really complicated dynamic where they are just full of soil-borne pathogens like rhizotonia that thrive on decomposing organic matter, because you have a ton of decomposing organic matter on the soil and then like really wet feet. So that was something that we noticed in quite a few tunnels. So just like good nutrient management, removing plastic every couple of years, and potentially cover crops to try to prevent that compost from really drying out in the first place and like incorporating it better. I know that's the challenge of like, we're trying to reduce tillage, but incorporating our compost helps us to avoid that like stratification. When I started to do this, I got really into this idea of acidifying irrigation water. And the more that I learn about it, the more hesitant I've become, because you're also like adding salts to the system when you do that. And so it can have this, there's kind of a balance of like, you need your irrigation water in the right range to adequately fertilize for your plants to be able to access nutrients. But if you're then contributing longer term salt accumulation, it's not ideal. And so like, I haven't figured out that perfect balance, but it's made me kind of go back to this really like basic practice that we talk about, which is just removing the plastic every 4 to 5 years when you're going to change it anyways, and relying on that maybe at least in addition to, if not instead of acidifying irrigation water, which I think is kind of a case by case decision. So yeah, we have this kind of perennial issue in vegetable production, especially organic, which is finding realistic ways to provide nitrogen without all that excess phosphorus and potassium. But often we are probably over applying nitrogen as well, and potentially not really considering our nitrogen credits in a high tunnel. Especially like when it comes to irrigation, we don't really have a habit of taking nitrogen credits in field conditions, but when all of our nitrogen, or sorry, when all of our water is coming from irrigation, taking a nitrogen credit from your irrigation water, I think is something that it's a practice that's really underutilized. And in Minnesota, you can get like a 90 pound per acre credit of nitrate just from your irrigation water, depending on where you are, which is a little scary from a groundwater public health perspective. But that's the reality. If you're using deep compost mulch or just like really heavily relying on mulch or compost as a mulch, sticking with plant-based composts, I think is one practice we can at least do. And like asking a lot of questions about your compost. I have had multiple situations with growers where they have purchased compost, not even realizing that it was compost manure, where like a company will sell compost and manure, and that's cow's manure and compost. And the compost is compost poultry manure, but it's not marketed that way. And just running into issues where like plants get salt stress after a heavy application. We did just come out with a new calculator tool to help small scale vegetable farmers figure out like a balance of inputs for their farms. And it's got a bunch of like more organic friendly options in there. It's a little clunky. It's not a perfect tool, but I'm happy to like meet with anyone and talk about how to use it. It's on our website. And then beyond that, I think one of the things coming out of this project was realizing like we have a ton of phosphorus on the landscape of diversified vegetable farms. And so in addition to finding ways to reduce inputs, we really need to be thinking about mitigating the impact of what's already there. And so, basic soil health principles, anything that keeps the soil in place, like cover crops, are going to keep phosphorus in place, but also thinking about things like planting perennials and berms and swales, and really working with like your conservation agencies, like your Soil Water Conservation District, NRCS, to think about water movement on the farm. And if you're in an urban environment, like really thinking about that around storm drains. So that was a super quick overview of the project. Thanks for taking time to listen to it. Do you want to do some questions now, or Rue, do you want to do your part and then come back all together at the end?
I think if there are any questions, let's take questions now.
Okay.
you had said that, typically levels are very high. Here, I'll turn this on, sorry. In, vegetable farms for nitrogen, nitrates, especially in tunnels, nitrogen and phosphorus and that sort of thing. Um, and I'm wondering what the basis for that. You kind of said that people are getting their recommendations from different places, but just from looking around, I get wildly different recommendations depending on where I look.
Yeah, that's a
And
great point.
and with a really high demand, high value crop such as vegetables, especially for direct sale, I feel like there's a lot of value in being at the upper edge of those limits. Um, so I guess I'm just wondering, high compared to demand, high compared to vegetable crop demands, or high compared to average soil tests across the state?
Yeah, great question. So high relative to vegetable crop demands. And so you bring up a good point that you get different recommendations from different places. And there are two kind of general philosophies about nutrient management. A more conservative philosophy that the University of Minnesota has taken is this idea of figuring out like how much your crop is going to use and then applying that amount to then have your crop like bring it back down and like apply it again next year. And that comes in part from a conservation mentality, but also just from like in conventional agriculture, like a more money saving mentality, I think, too. And then there's this build and maintain approach that comes really from like co-ops associated with fertilizer sales. They want to sell you more fertilizer. And to some extent, I think organic agriculture has this approach too, where like you just keep your levels really high to know that like you're going to have enough. And I think one of the challenges with that is there is a trade-off where if your levels of phosphorus and nitrogen are consistently high, you also are losing that to the environment, which has impacts both on like how much, I guess, how much money you're spending on inputs, but like it also impacts to the health of our freshwater ecosystems. And so the numbers that I'm using are based on our nutrient management guide for commercial vegetable farmers in Minnesota. And we just revised our high tunnel recommendations, and those numbers are like way higher. So we're recommending really high amounts of nitrogen in a high tunnel, like 350, 400 pounds per acre, which is, quite a bit higher than field conditions. So yeah, that's the framework for all of that.
Okay.
Carl, you've got your hand up.
Yeah. Hi. Thanks, Natalie. Good project you got going here. Two things. Does University Cells Lab or who would test the nitrate in water? And then
A lot of labs will. You can
yeah,
send it to, I know the U of M soil lab will,
the
probably
Cells Lab.
University of Wisconsin lab will.
Yeah.
Private labs will test your nitrates in your water.
Okay. I threw that in the chat. I'm only familiar with that out west where it's really dry and the nitrate sticks around a little more. And the other question or comment, I think I found one manufacturer. It'd be nice if these high tunnels had an automatic plastic roll-off thing, kind of like you see on those grain tractor trailers. So
Yeah,
the
it would be.
I think they're
Yeah, for
out
now,
there.
like the recommendation is not to be unrealistic. Like take your plastic off every winter. That's
Yeah,
obviously not going to happen. It's just like in that year
yeah.
where you're going to replace it anyways, consider leaving it off.
And then if you have the room, the high tunnels that are on the wheels and you can just move it over.
Yeah,
I kind of like that
very
idea.
nice.
Yeah, thanks.
I have a quick question. So you mentioned that soil pH and salt accumulation were two of like the most common reasons for dropping off the production. Are there like certain symptoms that are associated with those so a grower could know like which one
Yeah.
of those?
And I should say there's the other like major reason that we did not talk about in the study, which is soil-borne pathogen accumulation, that there are just certain diseases that build up in the soil and like become really challenging and problematic. But those two things, so usually if you have salts that are too high, you are going to see those problems in seedlings. Like you're just going to have seedlings dying or looking stressed, or transplants looking really stressed. And there are certain crops that are more susceptible than others. So I'm going to pull up my list before I say the wrong thing. But having a couple of those like indicator crops can help, in addition to just like when you do your soil test for the year, you really want to consider like, oh yeah, sorry, I'm losing my screen here. You really want to consider just testing for soluble salts too. Ideally, you could be testing for salts before you're getting to the point that you're seeing crop stress, and that being like the way that you figure it out. So the crops that are really sensitive would be carrots, green beans, onions, radishes, raspberries, and strawberries. So those are crops you're going to see issues in before anything else. And then the pH, I think it's like the ideal pH would be like 5.8 to 7 or something. And at like 7.2, 7.3, I don't know that you're going to see like any really specific impact. It might just be like, you know, slightly lower yields that you can't attribute to anything. But once you get quite high, what we see is that even if you have a lot of nutrients present in your soil, like your plants will be nutrient deficient. So like you might have applied a ton of potassium and your plants look potassium deficient, and then are potassium deficient if you do a foliar test. And that's where that balance of like dealing with irrigation water, I think, is really tricky, because sometimes it's actually in a system where you need nutrients to be soluble, which I guess is any system, but like in a high tunnel, the pH of your irrigation water can be just as important as the pH of your soil when it comes to your plants being able to access potassium. And so if the pH of your water is super high, it may still be worth acidifying that water, even if in the long term you're like potentially contributing some salt problems to the soil. Versus like if just the pH of your soil is high, yeah, then again, maybe you don't want to do that because you're contributing more salts to the soil. But yeah, in that short term, I think for some people, acidifying water is probably the best route, even if it has some longer term management considerations associated with it. Sorry, that was a really rambling response.
No, that was great. Thanks.
Natalie,
did you-
I'm curious about the cover crop association with poorer soil health outcomes.
Yeah.
Since I'm
Sorry,
about
I
to talk
didn't
about
say
cover
anything about that.
crops.
So I think what was like, we were not doing a replicated research trial here, right? Like we went to 100 farms and said like, how often do you plant a cover crop? Every year, every few years, never. And the average farm in this study had only been in production for 7 years. And I think cover crops like maybe take a long time to show benefits. We did not have a super robust way to collect data around cover crop use. We also just maybe had like factors that were stronger drivers of like more strongly correlated. We did not see, kind of my initial thing that I thought of was like, oh, if you use more cover crops, you're probably using more tillage to terminate those cover crops. But we saw no association there between frequency of cover crop use and frequency of tillage. So I think like, maybe it's a cop-out answer, but we were just like, there's probably not enough time and enough like detail in a study like this to actually see a response versus a study where you're like planting a cover crop and then looking at the soil and collecting biomass. I'm part of a group doing like a collaborative trial on high tunnel cover crops right now. So we had 40 farmers across Minnesota, Wisconsin, and the Northeast plant a winter cover crop in the fall slot. So like after their tomatoes or cucumbers. And then we have a smaller group that's doing it in the spring slot where they planted spinach over the winter. And then after harvesting their winter greens, they're doing like a quick little cover crop. And then we'll have people doing a summer cover crop. So I think we'll have much better data from that. And if anyone's interested in that, we're still recruiting people for the summer or for next year. So feel free to reach out if you want to be involved. You've got your hand raised, Red Door Family Farm.
Yeah. Well, one thought that I had since I raised my hand was just that maybe the reason I think a lot of people use cover crops and then they will spray to terminate them, and that's a way to keep tillage low. Doesn't work for organic vegetable farms, obviously. But that might be why, they might have some of the lower tillage, but still also be lacking in soil health metrics. And kind of skewing the data that way. I don't know. My question though was about adding sulfur to manage pH in the high tunnel. So we do have we tend to have slightly high pH, like in the low 7s, not up in the 8s or anything. And slightly alkaline irrigation water, but neither are very strong. And we have checked soluble salts periodically, and they're not in any sort of danger zone. So I've just been managing with sulfur, and I know a few other people that do the same, and I'm just wondering if there's that's way easier than acidifying the irrigation water. But I'm just wondering if there's long-term considerations there that I might be walking into.
Yeah, no, I think using sulfur is a really good tool, especially if you're in that 7.2, 7.3, because pH is on a log scale. And so to change it from 7.2 to 7 is a lot easier than from 8 to 7. And so sulfur, the only reason we don't do sulfur more, I think, on a larger scale is that you need a lot of sulfur, especially if you have high organic matter or clay soils, just because the buffering capacity is so high. But a tunnel is a pretty small environment where it's not a big deal to do it. So yeah, I think sulfur is a great tool for keeping your pH low. It doesn't address your irrigation water, but it's still a tool to manage your soil pH. And I think something that when you're testing your water pH, testing your alkalinity as well is super important, which is very confusing because we say alkaline when we refer to basic irrigation water, but alkalinity is a completely different measurement. And if your alkalinity is really high, that's in some ways more of a big deal than high pH. Although that's not going to be managed with acid.
Is there a way to manage that besides reverse osmosis?
I think it's just if you have really high alkalinity irrigation water, it becomes that much more important to get rainwater in there, whether that's removing the plastic, or some people who have plows will just plow snow into their tunnels. We haven't had a lot of snow lately, but yeah, just getting non-irrigation water in there becomes more important.
Gotcha.
Rue, should we shift to you so we have time?
Sure
I don't
thing.
want to take over the whole meeting.
This has been really great, Natalie. I'm glad you're able to join us. All right, I will share my screen. Okay, can you see my slideshow? Yep, great. So I am going to talk a little bit about assessing cover crops at this point in the year and into the spring. And I decided to talk about it more from the point of view of weed suppression. So the way I think about weed suppression with cover crops is that they can suppress weeds while they're growing just by outcompeting them for nutrients and water. after you terminate the cover crop, if you leave the residue in place, they can suppress weeds through just preventing light from getting to the soil, and so preventing weed seeds from germinating. But also with residue that is left in the soil, if you till it in, there are the cover crops that have an allelopathic effect, like cereal rye is the one we talk about mostly. And then also cover crops can provide mulch for cut and carry mulching if you want to not use that as an in-place suppression on your cash crop, but you're taking that mulch somewhere else. And there's a range of different amounts of mulch or amounts of cover crop biomass that you might need for this. And so these estimates that I'm sharing, generally, like the more research you look at, the more of a range you're going to see. But some common figures that I have seen are a bit over 2 tons per acre. This is from research in corn and soybeans. If you want your cover crop to be outcompeting weeds while it's growing, if you get up to around that amount of biomass, you've probably had pretty reasonable competition. If you're looking to leave the residue in place, in particular for a system like roller crimped rye, you are going to be looking for more like 4 to 5 tons per acre of that biomass. And if you're looking to provide mulch for a cut and carry system, then what I have found in mulch potatoes is that getting up to levels around 8 to 10 tons per acre is going to be necessary for mulching a crop like potatoes. Now, all of these amounts are measured in amount of dry matter per acre. And so for something like mulching potatoes, that's more than you are generally going to be able to provide in place. So there you would be looking to either grow cover crops on a larger area than where you're going to grow your cash crop, or you're going to be needing to take multiple cuttings off the same area. So I wanted to give you a couple of visual ideas of what this might look like in the field. And here's an example of some plots where we were growing rye and looking at different termination methods. And I took some photos from above, as well as someone took a photo of me. So you can see that that's about probably 4 to 4.5 feet high on that rye. And you can see what it looks like looking from above. And that gave us about 6.5, a little over 6.5 tons per acre. So that's an amount that actually when we did the research into roller crimping in this location, we got really nice weed suppression. We did also have a lot of, that was good weed suppression of annual weeds. We did also have some perennial weeds that did not care about that rye. They popped right through. Here's another example where we're down in more the 2.5 tons per acre area. And you can see what that looks like looking from above. And this was more like about 3 feet high. So if you want to figure out where you're at.
I can't hear you at all. Is that on my end?
Oh, is anyone else having trouble?
Well, I can hear you now. It might have been. I don't know. Sorry.
Okay.
I've been able to hear you the whole time.
Okay. All right. Good to know. So the way that we typically measure biomass in our research, and this is something that would be feasible for you to do as well, is to use a quadrat. This one is 1 foot by 1 foot, and we lay that down. Sometimes we have to thread the cover crop through it and cut everything off at ground level. If we're sampling a field, we would take several samples through that field and then dry that plant material down completely. And I'll go through the math just kind of quickly. So for example, if we got 1/2 pound of dried plant material and we had taken 4 of those 1 by 1 squares, so we have 4 square feet, then going through the math, that gives us 0.125 pounds per square foot, multiply that up by the number of square feet in an acre, and that gives us about 5,500 pounds per acre, which is 2.72 tons to the acre. So that's about in the area where you might expect that, so similar to that second set of photos that I showed you, you might expect that that cover crop will have suppressed weeds nicely while it was growing, but you're not necessarily going to expect that to do a great job if you're looking to roller crimp that down and plant into it. Now, Natalie was talking a bit about how much nitrogen you might get as a credit from cover crops, and you can certainly send samples in and get them tested for their nitrogen content as well as other nutrients. But a good estimate that people use is when the plants are flowering, they're going to have higher levels of nitrogen. For legumes, they're going to be about 3%. And then that's going to go down as they get past flowering and seeds start to mature, down to about 3% for legumes. And then for grasses and other cover crops, non-leguminous cover crops, that's going to be about 3% at flowering and about 2% as the seeds start to mature. So that can be pretty significant. In the example I worked through before, if we had about 5,500 pounds per acre, and say that's a grass that is flowering, so multiply that by 3%, would give us about 163 pounds of nitrogen that's present in that cover crop tissue per acre. You do then have to consider how much of that nitrogen is going to be available in the first year. So that's going to be influenced by how much carbon there is in that cover crop as well, the carbon to nitrogen ratio. And also the soil conditions can have a big impact on how much of that nitrogen is going to be available to the crop, and also how much of other nutrients are going to be available to the crop, because that green material has to be broken down by microbes before it can be available for the plants to take up and use. If you say mow that with a flail mower and then till it in so it's all finely ground up, you're going to get faster breakdown and availability of that nitrogen. And at most, you might be looking at about 50% that's available. So again, in our example, that would translate to a bit over 80 pounds per acre. If you leave the residue on the surface, it's going to break down much more slowly, and so the nitrogen is going to become available over a longer period of time. That residue on the surface is also going to keep the soil a little bit cooler, and as well as hopefully suppressing some weeds for you. So that cooler soil is also going to have an impact on the mineralization and availability of nitrogen to your crop. So if this is something that you're interested in trying this year, I would always suggest trying a strip where you are, however you are leaving that cover crop, whether you're tilling it in or whether you're leaving residue on the surface, that you would try a strip and look at whether you can reduce your fertility amendments without impacting your yield. This is something where we really could use some more research in vegetable systems. I talked a little bit about some of our research a couple of months ago, and we are starting to see some better management methods where we can make sure we still have good availability of nutrients to the crop in these reduced tillage systems. I did want to end by just talking about some opportunities to learn more about, or to contribute to us learning more about cover crop management in vegetable systems. And I'm first going to talk about the Wisconsin Cover Crop Citizen Science Data Network. And this is a network that is a collaboration between Michael Fields and UW Extension, with a couple of other partners as well. And I'm just going to show you on the website some of the information that you can get through this network. So this network is across a wide range of different farms. So a lot of the farms in this network are row crop farmers. You can see on the map the dots are the points where we have some data about cover crops on farm. And the different colors of these dots are going from for the amount of full biomass of those cover crops. Paler means less, up to darker green is more, or gray is no data. And there are a number of different filters that you can apply if you are looking for particular types of soil, particular cropping systems, tillage types, so conservation, conventional, or reduced tillage systems based on the amount of residue that's remaining. And you can also focus on particular cover crops. So I'm actually going to just look at what we see if the prior crop was a vegetable crop. And we don't have as many vegetable production systems in the network at the moment, which is part of why I'm talking it up to all of you, because I'm hoping that you might be interested in being part of this. So if I click on one of the dots down here, down in Kenosha County, you can see the kind of information that people are providing to this network. So here we see the cover crop mix that was planted on this farm, the seeding rate for that mix, how it was seeded, that it was a vegetable crop prior to that, when it was planted. And I'm going to go down to look at what the full biomass was. That was up around 5 tons per acre, which is a really good amount. And then you can also submit pictures. So it's always helpful to me just to see what that looks like as well. And then depending on how much you want to nerd out on the data, you can go to a graph, and I'm going to choose, let's see, if I go down here, I'm going to choose cereal rye and look at that based on the date that it was planted from around July through to November. And you can see up here the amount of biomass that you get from that. So up to about 4 tons per acre. And you can see a bit of a trend. There's not a really strong trend here, but certainly later in the season, we're not seeing these really high biomass amounts accumulating by the next year. So let's see, I will close out of that. And I also wanted to mention the Great Lakes Cover Crop Project. So this is a project that you might remember Etienne Sutton talking about a couple of months ago. This project works a little bit differently, where people can they can submit a cover crop canopy photo, so a photo from above, which is put through image analysis to figure out the amount of cover that crop is providing, how much of the ground it's covering. And then by multiplying that with a height measure, you can get an estimate of the amount of biomass that cover crop is producing. So that's something where that has worked out pretty well for some of the cover crops like cereal rye. It's a bit more difficult to do when you're looking at some other cover crops where there's been less research, or in particular when you're looking at a cover crop mix. But that is something that there's active research on, and if that's something you're interested in participating in, you can get in touch with Etienne for the Great Lakes Cover Crop Project. Probably the easiest thing to do is Google Great Lakes Cover Crops Project. And so that involves taking a survey, submitting a photo and a height measurement. And if you're interested in being part of the Wisconsin Cover Crop Citizen Science Data Network, you can get in touch with me. And that also involves taking a survey and submitting a sample of your cover crop. So I am going to leave it there, and we can talk about cover crops if anyone has questions or comments.
Thanks, Rue. That was awesome. I have a question. I love the idea of, you know, taking multiple samples and drying them down and doing that and getting actual numbers. I manage everything by the bed, and so I would have like some odd hundreds of different analyses to take, and then to take a representative sample within each of those. So the photo thing is great. Is there any, I guess, you kind of did this and showed a good example of rye just to give sort of a rough spread of where you're at, but I'm wondering if there's more like rudimentary baseline, like if you have this sort of a mix and it's about yay high and about that thick, you know, I don't know. I guess I'm just wondering if there's simpler ways to get a less accurate calibrated metric to use for estimating nitrogen credits, for example.
Yeah, there are some examples of those, and I can hunt them up and send them to you. Again, they tend to be better developed for some of the more common cover crops like cereal rye, and it is always harder with a mix. But I'll find those and send them to you, and we can send them out to the group as well. I am really interested in the photo and height measurement option as well, and it's something where I am hoping to get some of those, like do some ground truthing of some of that information on farm. So that's why, you know, if you're interested in this, feel free to get in touch with me. And I can't be everywhere, but there are definitely a few places that I'm hoping to visit this year and take some samples so I can get that actual biomass estimate and then compare that to what we're seeing with the photograph and the height measure. And so between what we're doing in Wisconsin, I know there's similar projects in Minnesota, and what Etienne is doing for the Great Lakes region, that's where we're hoping to get so that it would be easier to just get an estimate. That image analysis, I know it looks a bit challenging. It's actually super easy to use. So there are apps that you can get for your phone. You literally just stick your arm out to the side, take a photo, put that photo through the app, and it'll tell you what the percentage ground cover in is. And then if you have a yardstick with you, the ideal of where we get to is that you can just take a photo, maybe you tattoo a yardstick on your leg so that you can, or you just know how high your boots come up, so that you can get that estimate more easily.
And then is there, and I was sort of thinking that too, is just if I use that tool a few times, I might almost kind of calibrate my eye a little bit.
Yeah.
Is when you're measuring height, I feel like that could be really tricky to decide which number to use there. You know, like I can obviously tell that 1 foot is not 2 foot, but is it 10 inches or 14 inches might be pretty tricky depending on how you kind of draw that line. Is there guidance on that?
Yeah, generally what I've seen is if you've got something that like the leaf is sort of bending over, that you just do that to the point, like you don't stretch the leaf up. You just look across, and it's where that leaf is bending over.
Right.
I also really loved your pictures of, I see the value of doing the more intensive measurements, but I think there are a handful of farmers who I can see doing that. And then like hopefully, I don't know, hopefully once we do some more ground truthing, it could be really cool to just have a little fact sheet that's like photos of different cover crops at different, you know, like here's the crimson clover row. Like, does it look like this or
Yeah.
like this or like this or like this? Like, here's your nitrogen credit.
I think
And I
that is
wonder
where
if
we need to get
there's
to.
some opportunity to like, I feel like we could maybe have some people power in Minnesota to like do a bunch of photos like that over this summer if we were coordinated about it and see if we could get something together.
I think that's where we need to get to. So yeah, when we send out the recording for this, maybe we can do another call for farmers who are interested in knowing more about yeah, how much biomass they're getting, how much nutrient credit they might be able to take, and between getting more photos and I think getting folks like me and Natalie and Stefan and Emily out there to take some samples. It'll be great by next year to have something like that together where we've got those photos.
That's excellent. Thanks. I was really surprised that it's only 1% more nitrogen credit for a legume crop than a grass crop. Was anybody else surprised by that?
I was surprised by that when I learned that. Yeah.
That's essentially because like non-legume crops do such a good job of preventing leaching, right? They're just holding all that nitrogen in the system.
Yeah.
Okay.
And I guess, 4% versus 3% is 25% more is the other way to look at that. So that's a big.
Yeah.